Hello everyone, welcome to this video. Today we'll discuss what is ECMP or equal cost multipath in routing. When most people learn routing, they are told that a router selects one single best path and sends all traffic through it. This makes intuitive sense because routing protocols are designed to calculate the best path on the basis of metrics like cost or next hop or maybe local preference, etc. But what if two paths are equally good? What if both paths have the same cost, same preference, and same priority? Should one path sit idle while the other is fully utilized? But that would mean a waste of bandwidth and a waste of available network resources. So, this is exactly the problem ECMP solves. To understand ECMP, we must understand traditional routing behavior. Routers build routing tables and select a single best path to each destination. So here we have the R1's routing table, which can have multiple routes and their corresponding next hops, along with other properties as well. So here we can see that R1 can reach router R4 by taking the next hop R2, and similarly it can also reach R4 by taking the next hop R3. Even if multiple paths exist, generally the router installs only one path into the forwarding table. So in a default case, both of these routes might not be installed in the routing table simultaneously. So apart from the primary path, the other paths remain unused even though they are perfectly valid backup paths. This means that by default, traffic flows only through one link while other links remain idle. ECMP changes this behavior completely. When the routers detect multiple routes with equal cost, it installs them into the forwarding table instead of choosing just one. So this allows the router to distribute traffic across multiple equal cost paths. Instead of wasting available bandwidth, ECMP allows full utilization of network resources. Now the important question becomes, how exactly does the router decide which traffic goes on which path? The router cannot randomly send packets without a strategy because that could cause serious network problems. There are two main methods that routers use to distribute traffic. The first one is per packet load balancing. In per packet load balancing, each individual packet may take a different path. For example, one packet may decide to go from R1 to R2 to R4, while the other may decide to go from R1 to R3 to R4. While this distributes traffic evenly, it introduces a serious issue. Packets may arrive at the destination out of order. This is especially problematic for TCP, which expects packets to arrive in sequence. Out of order delivery can reduce performance significantly. To solve this packet reordering problem, routers use per flow load balancing. Instead of balancing individual packets, the router balances entire flows. A flow is defined using 5 parameters: source IP, source port, destination IP, destination port, and protocol. The router applies a hash function to these values and assigns the flow to one path. All packets belonging to that flow follow the same path, ensuring proper packet order. Many routing protocols support ECMP. Protocols like OSPF, ISIS naturally support equal cost multipath routing. BGP also supports ECMP but often requires configuration. The routes must qualify as equal according to BGP's best path selection process before multipath can be enabled. For ECMP to function properly, routes must truly be equal. This means they must have the same metric, same administrative preference, and in BGP the same path attributes. If the attributes differ, the router will select only one best path and ECMP will not be used. ECMP is also heavily used in modern data center architectures, especially the leaf spine topologies. In this design, every leaf switch connects to multiple spine switches using equal cost links. This creates many equal cost paths between devices. ECMP allows traffic to utilize all these paths, enabling massive scalability and high performance. This is how cloud providers like AWS, Google, or Azure scale their infrastructure. So to summarize, ECMP allows routers to use multiple equal cost paths simultaneously. This improves bandwidth utilization, increases redundancy, and enables scalable network design. Without ECMP, network capacity is wasted, and with ECMP, networks become more efficient, more resilient, and more scalable. Thanks for watching and consider subscribing.